We can continue for second presentation is by engineer Osama Khalid Abdulaziz.
Hi, this is Osama. Hi, this is Osama Khalid, and today we will talk about cost evaluation of post-tension slabs in multi-story buildings considering seismic effect. Our outlines will discuss introduction, case study, design methodology, results, cost evaluation, time analysis, and conclusion. From literature reviews and case studies, it is proved that the slab element plays an important role in the overall cost of building, as the slab element represents about 64% of the total cost of building, while the vertical element represents 13%, raft foundation represents 21%. So using the technique that positively affects this element thus will positively reflect on the building as a whole. It is known that post-tension technique is distinguished from traditional flat slab method because of the preloading of the member that leads to a lot of advantages, such as larger spans with thinner cross sections, reduced total weight of building, lighter structure requires a lighter lateral resisting system. Also, there is a deflection control, P over A, prevent tensile stresses, high punching shear strength, and reduce floor-to-floor height. The problem is the previous researches on this topic were studied at the level of the slab element only, regardless the effect of post-tension on the vertical elements and foundations, especially studying the savings in materials without the exposure to labor. In addition, the lack of attention to study of the construction time for each of the two systems. So our objective is to make a comparison between the two systems, post-tension flat slab system and traditional flat slab system, not only at the level of the slab, but at the level of the all building elements, taking most aspects into consideration, such as structural behavior, cost, and time. After obtaining the required quantities of concrete, reinforcing steel, and pre-stressing steel, and by considering labor crews and productivity rates of each of construction items, cost and time analysis are performed. The case study is a multi-story residential building consists of ground plus 12, designed by the two approaches, post-tension and RC, for a various span of 6 meter, 8 meter, and 10 meter. The layout is a square plan of 5 by 5 bays, 28 columns, and 4 shear walls. All buildings are rested on a raft foundation. Design methodology. The analysis and design of the building are conducted using a lot of software programs, such as ETABS to design vertical elements, and SIP program to design the raft foundation, and RAM concept to design the slabs, either post-tension or traditional flat slab, and Revit to make a bill of quantities, and Primavera to assign the construction items and their durations. After completed the design stage of the 6 buildings, 4 main comparisons are performed. The first one, the slab thickness is lesser in case of PT slabs by 10 to 15%. The second one is the story stiffness and the story drift. Despite PT slabs are thinner than traditional RC flat slab, but PT slab act as a frame with vertical support since they are much stiffer than RC, as we see here, and this leads to better behavior against seismic loads. On the other hand, PT slabs prove that they have high deflection resistance due to the presence of tendons. And finally, when we're looking at the punching of the slab, the designer can consider additional resistance of punching in PT slabs due to the vertical component of tendon and the pre-stressing force. Cost evaluation is performed through quantity takeoffs and pricing. 3D model is made for all building using Revit program, and are summarized in this table. This is for traditional items, and this is for pre-stressing system. While the pricing for material and labor is performed according to Egyptian labor market and are summarized in these tables. We conducted a comparison at the level of concrete element to obtain the savings in each span. The savings occurred in slabs when using PT system is 9 to 19% for spans over 6 meters, and the savings in vertical element is 4 to 14%, while the ref foundation has a minor savings, it's about 3 to 5%. We also conducted a comparison at the level of total building costs. The savings obtained in this level when using PT system is 7 to 15% for spans over 6 meters. The savings in concrete only is 6 to 11%, while the savings in reinforcement, either pre-stressing or non-pre-stressing reinforcement, is 12 to 33%. Finally, the savings in material in general is 9 to 24%, while the savings in labor is 2 to 6%. Time analysis. A time analysis is performed for substructure and superstructure activities based on quantities and productivity rates. Number of crews is assumed to be the same for all buildings to obtain fair comparison. The time duration is obtained by this equation, duration equal to quantity divided by production rate. This is for RC slabs, and this is for post-tension slabs activity description. And this is our crew structure. After obtaining the duration of all buildings, a time schedule was made for all construction phases. Using a Primavera program, the time savings when using PT system is from 25 to 37%. If we want to benefit from these savings, we can do it by invest this saving through return on investment. The annual return on investment in Egypt is about 8 to 13% of the total cost of building. We consider 8%, and thus will gain income that can be deducted from the original cost of building. The total building savings when considering investment will be 9 to 18% instead of 7 to 15%. The following conclusion are drawn from the present case study. Firstly, post-tension slabs with spans over 6 meters offer direct cost reduction in concrete by 6 to 11%, pre-stressing and non-pre-stressing reinforcement by 12 to 33%, material by 9 to 24%, labor by 2 to 6%, slabs by 9 to 19%, columns and walls by 4 to 14%, ref foundation by 3 to 5%, total building by 7 to 15%. Post-tension slabs with spans over 6 meters also offer direct reduction in construction duration by 25 to 37%. And when we consider the time return on investment, the total savings in building cost will be 9 to 18% instead of 7 to 15%. Post-tension buildings have a better behavior against seismic load, and post-tension slab has lower value for deflection than RC, higher punching shear strength obtained by using appropriate layout of tendons due to the vertical component and the axial compression stress from tendons. We can notice there is a minor saving in the comparison of span 6 meters, while a considerable savings occurs in spans 8 meters and 10 meters, which prove that the post-tension slab can be recommended for multi-story buildings with spans over 6 meters. This is our references, and thank you.
Thanks for the presentation. And we will continue to third presentation by Hilal Nurberau and Associate Professor Can Baran Aktaş from TED University, Computer Engineering, Department of Computer Engineering, Ankara, Turkey, which entitled The Importance of Virtual Reality and Augmented Reality for the Architecture, Engineering, Construction Industry.
I am Hilal. Sorry.
Yeah, please play.
I'm Nurberau. I am a senior student at TED University Computer Engineering Department, and today I will give a presentation about our research topic, the importance of virtual reality and augmented reality for the AEC, Architecture, Engineering and Construction Industry. Virtual reality and augmented reality technologies are considered to be one of the most influential innovations anticipated in the near future to transform the architecture, engineering, and construction industry. Their applications have already started to make noteworthy gains around the world, and it is expected that their use will increase moving forward. In the construction industry to date, VR and AR have effectively been used in scheduling construction projects, for monitoring project progress, in training workers, time and cost management, and in the management of quality and defects. Although there are similarities between the two technologies, there are certain differences that differentiate the two and provide certain advantages depending on the purpose. As the definition of AR has developed as an extension or modification of VR, AR is closely related to VR. It incorporates real-life and computer-based scenes and images by superimposing the view from a real-world physical environment with the objects from a virtual world to provide a seamless and enhanced view of the world. VR goes a step further with 3D visualization. It is generally defined as a 3D synthetic environment or structure generated by computers that gives the user a sense of being immersed in a real world. So what are the shortcomings of 2D design and execution in construction? Traditionally, construction projects have been designed and executed in 2D, first by hand-drawing plans and later by computer-generated 2D drawings. Nonetheless, there still is an inherent problem with using 2D for construction projects, as technical personnel are required to visualize drawings and special relationships between building elements and translate into 3D and effectively communicate with other stakeholders. A further problem area is poor portability and incorrect handling of drawings. So I will talk about AR and VR applications in practice. AR and VR technologies have found applications in a wide variety of industries, including engineering, healthcare, education, military, sports, entertainment, and cultural heritage. AR in construction. Augmented reality enables information that is captured in the physical world to be viewed on site and is thus necessarily consistent with the needs of the construction site. AR systems are used to capture and distribute data to field users. This also reflects the means of contact between project members and knowledge on the project. Benefits of using AR in construction projects are scheduling and project progress tracking, quality and defect management, time and cost management, employee training, and safety management program. Now we are in construction. Immersive environments provide opportunities for better communication between stakeholders, better spatial understanding of virtual designs, better understanding of design decisions, and recognition of design problems that would not otherwise be found. And it can also predict human building experiences that can feed designers and researchers to accurate user experience data. VR technologies are gradually incorporated into the construction industry with these advantages. These technologies can be used for worker training, safety management system, progress tracking, labor management, defect and quality management, and project visualization. VR is very suitable for providing realistic and cost-effective virtual environments for security education. Now I will talk about some capabilities of the environment. First one is hardware abstraction. Help for the hardware needed is important, but how well the toolkit describes the hardware interface information is just as essential. Although a less standardized interface may be better suited to the unique features of the computer, the standardized interface makes the program more versatile and simpler to update, manage, and understand. Locally distributed application. In addition to raising the application frame rate, delivery has other advantages. Display channels available for the application or increasing the number of input devices. It enables the use of additional computers for simulations and other computer-intensive activities. And distributed environments. For distributed systems connecting multiple computers, the idea of connecting machines and users to distant locations around the network opens up the possibility of communicating in a virtual world. Another one is rapid prototyping. It is important to be able to run and interact with the application without using any special equipment, because most development groups can only access one or two full VR installations. Otherwise, it is possible for developers to spend a lot of time waiting for the devices to turn on. And the last one is runtime flexibility. VR applications usually take a long time to start. Processes must be created and configured. Then the hardware is started and databases are loaded. When a small change is made, the time required to restart an application can render the system inapplicable. Now I will talk about some current VR softwares. There's various software commercially available in the market. These tools have been developed mostly by different firms, and each has a specific niche together with limitations. First of all, I will start with Iris Performer. It is a high-performance graphics API for machines running Silicon Graphics Inc. It can be used to create high-performance VR applications. Performer is a library of graphics based on C and C++. Iris Performer is a runtime programming interface with an in-memory scene representation. And there are some strengths. Tool has visual simulation features such as billboard geometry, light points, and clip texturing that are valuable for the development of VR applications for visual simulation. And there are some drawbacks. Limited platform availability is one of them. Iris Performer can work only in SGI machines. And limited hardware support is another drawback. There is no support for other input devices except for mouse and keyboard. Now I will continue with Word Toolkit. Word Toolkit is a VR library written in C, and there are C++ wrappers. VR Toolkit handles the specifics of reading sensor input, rendering scene geometry, and loading databases. It provides good support for most visual and acoustic output configurations, but don't include force output. And there are some strengths. It is widely used and it has a cross-platform. And multi-pipe support is another strength. The SGI version supports multi-pipe applications. This allows Word Toolkit to control case and similar devices. And there are some drawbacks. Device abstraction is one of them. If there's a hardware update, the program code has to be modified and recompiled. And performance is another drawback. Some VR libraries and libraries based on Iris Performer are not performed by the Word toolkits. The applications, potential benefits, and limitations of VR and AR technologies in the AEC industry have been covered so far. The high cost of AR and VR technologies and the general lack of AR and VR expertise in personnel are two major challenges limiting further dissemination of technologies in the AEC industry. Nevertheless, the non-technical conveniences and technical superiority in improving safety management, time and cost management, and defect and quality management provided by their use are too valuable to ignore. Their contribution towards scheduling and project progress tracking are also noteworthy for the field of construction. Well, thank you so much for your attention. If you have any questions, I can answer. Otherwise, that is the end of my presentation. Thank you.
Yeah, thanks for the presentation, and we will take the questions at the end of the last presentation. The last presentation is by Dr. Sertaç Uruç from Department of Civil Engineering, Kırşehir Aheyvan University from Kırşehir, Turkey. And the title is Climate Extreme Indices Derived from Observed Daily Temperature Data over 3 cities of the region, Turkey. Yeah, we can start.
Hello everyone, this is Dr. Sertaç Uruç speaking. Welcome to the 4th International Conference of Contemporary Affairs in Architecture and Urbanism. Today, I'm going to tell you, I'm going to represent my results from the study Climate Extreme Indices derived from observed daily temperature data over 3 cities of the region, Turkey. Dear organizing committee and dear colleagues, welcome again. First of all, I want to tell you the motivation, the motive of the study. The motive of the study was changing climate change, changing climate conditions, and increasing extreme events, increasing severity of the extreme events, increasing frequency of extreme events. That allows me to investigate the effect of extreme temperature change considering the buildings or built environment. So, what was the problem? What can cause the extreme temperature or temperature over buildings? When we look at the 3 phases of buildings, the design phase, the construction phase, or the operation, or let's say end-use phase, we can see the impacts of temperature in all these phases. For instance, the design phase or the construction phase, we use this as an input. We use temperature as an input for our design or construction. The coldest days or the hottest days can cause delays or increasing costs. Furthermore, what else? The operation or the end-use phase. Increasing demand of cooling or heating of the buildings can cause very high cost of service during the service life of the building. So, when we look at the 3 phases and the possible, briefly the possible effects, we can see that buildings are going to be impacted by temperature or extreme temperature during their life cycle, design, construction, or operation phase. So, we need to study the impacts. What can cause? What can be the consequences? What is the risk? You know, it's proven that the global temperature is increasing. And probably if we keep moving. When we look at the results of a recent study, we are not only interested in the observed period, but when we look at the future period, we can also see the temperature anomaly in a positive way, which means whatever the scenario is, the temperature is going to increase, especially in summer and autumn months. So we'll take action. We'll take action and start with it by analyzing the observed period, the behavior of the observed period. But how can we do that? To do this, we use extreme indices, extreme temperature indices, which can be effective for building design, or let's say which can be effective in the all phases of buildings, from design, construction, operation. We use the complex software to analyze these indices and use the data of 3 stations with the trace region of Turkey, Edirne, Tekirdağ, Kırklareli, and the data was supplied by the Turkish State Meteorological Service. The World Meteorological Organization's expert team on sector-specific climate indices released the indices for the climate studies to standardize the studies, or the, let's say, results. And these 13 temperature indices were selected among these indices. For instance, the hottest night, coldest night, hottest day, coldest day. We use these 13 indices to identify the behavior of the observed period temperature for the 3 stations. When we look at the methodology, we use 2 well-known trend analysis method, which is one of the rank-based Mann-Kalman trend test, the non-parametric test, and the other is noted trend analysis. We use Mann-Kalman trend test to analyze the temperature indices derived by the context software, the result of the software. Then to visually inspect and to justify the Mann-Kalman test results, we have also used the innovative trend analysis. When we look at the results for the daily temperature indices, for instance, hottest day, TNX, or the coldest night, TNN, or the rest of the indices, for the 3 stations, we can see a significant increasing trend from the Mann-Kalman result. Except the TNN, the coldest night at the Kırklareli station. We can see the trends, and also they are significant. Most of them are, let's say, significant. When we look at the results of innovative trend analysis, we can see parallel results with the Mann-Kalman test. From the innovative trend analysis for the Edirne station, for the Kırklareli station, or for the Tekirdağ station, when we look at the distribution of the values, the low, medium, or high values, we can see the increasing trends of the daily temperature indices. Moreover, we have analyzed the daily frequency temperature indices. And again, although not very similar to the daily temperature indices, we have also identified increasing significant trends. We have identified increasing trends for most of the indices, and also we have identified most of the increasing indices show significant increasing trends. So what I did on this study is to determine the 13 sector-specific temperature indices annually and investigate their trend behavior at the 3 stations of the race region. We have used the historical period data. And the results showed a dominant increasing temperature trend over the region. And these results also coincided with the other studies over the globe and also over Turkey. The result of this study indicates the increasing temperature range in day and night time over the observed period. The hottest night and day temperature also showed increasing trend. These changes over time will probably affect the material life too, regarding the building design and building construction and building operation. Edirne Kırklareli and Tekirdağ stations also showed significantly increasing trends for the hottest night and average daily maximum temperatures in the study. Hottest day index also showed increasing trend for all the stations, with significant trend for Edirne and Tekirdağ stations. To sum up, as a concluding remarks, it's now an urgent issue that needs attention with the evolving climate conditions. So, the major climate factors that are dominant for the building life cycle must be evaluated to make proper decisions for the design, construction, and operational phases of buildings and update the performance criteria. Thank you very much.
Yeah, thank you. Thanks for the presentation and all presentations also.
Thank you, dear Dr. Halil. Since at the beginning of the session, I didn't record while I was introducing you to the author. I will once more introduce you so to make sure that I recorded the document. Dr. Halil Ibrahim Burgan, who is taking the session of civil engineering, is a doctor in Akdeniz University from Faculty of Engineering from Turkey. Yes, please, doctor, the floor is yours.
Yeah, we can make roundtable questions and answers. Is there any question to presenters from audiences or presenters each other? Maybe the presenters say last sentences about their studies. Do you want to say something? No. Okay, I can a small question. Yeah, we have 10 minutes. Yeah. I want to ask to Osama Khalid. Is there any limitation or disadvantages of post-tension technique? Is there any unapplicable area for this technique?
Hello, Dr. Halil.
Hello.
Hope you are fine. Yes,
Yeah.
there is disadvantages, but these disadvantages has been overcome. The disadvantages, the system needs special trained laborers and supervisors, but many subcontractors firms have been established recently. They became specialists in this technique. Also, it's difficult to make a further openings after casting in this system because these post-tension cables, which are stressed and slabs are fully compressed after casting. So it's difficult to make a further opening. This may happen because of many reasons, such as changing the function of the building or make some modifications that weren't taken into consideration before. But the general arrangement of tendons layout must be the guide to make these openings. And by calculation, we may consider a strengthening or not. So this issue has been overcome. That's it.
Mm-hmm. Thank you for the answer.
Thank you.
And is there one more? No?
Actually, may I have a question, Doctor?
Yeah, please.
Regarding your presentation. I'm dealing with the same issue with the statistical distributions and working not with the. I'm working with just annual maximum of rainfall with the standard duration, but I want to ask that how many distributions did you consider for the evaluation period?
I presented it, but
probably I missed it.
I don't remember 10 distributions, but the main distributions. I didn't consider 4 or 5 parameter distributions, for example, or the other weight B distributions, because they are not very wide distributions in hydrological sciences. I selected main distributions for the same.
So the specifically the generalized extreme value distribution, it covers the extreme value 1, 2, or various, let's say, extreme value distributions. Can we consider generalized extreme value as a family of extreme value distributions in your study?
If I miss, please correct me. I understand as generalized extreme value distribution is the mother of the distributions of these distributions.
Yes.
But I couldn't say this because the function of these distributions are different from each other. For example, Gumbel distributions is suitable for example, flood discharges. But we can use these distributions for maximum or extreme rainfalls. So I have 2 fitted Gumbel distributions. For one of them is the shortest observation, and the other one is the Western North station. So these are we can say this outer stations because of the geographical location at a very short period. But I can say for general, the generalized extreme value and log logistic 3-parameter log logistic distributions are very impressive at the coastal sites in Antalya.
Thank you very much.
Thank you too.
Well, thank you very much. Thank you very much, Dr. Neil, for your support.
Just one thing. I want to congratulate Hilal Nur for her courage as an undergraduate student, and good luck in her professional career.
Thank you so much.
I can ask a small question to you. Is there any free available, not commercial, and open access virtual reality or augmented reality softwares? You mentioned the softwares are commercial softwares. Just this.
Yes, in our research we talk about commercially available softwares, but I have no idea about in detail whether there is free available softwares. But many firms give these advantages. You can have the chance to freely try the software for 1 week in many softwares that I meet in other areas. Maybe there can be this option. You can try it in free for 1 week, and if you are okay with the software, maybe you can get a license after that. And also the most popular programming languages are for AR and VR are C#, Java, C and C++, and mostly these technologies are written by these languages. That's all. I hope this helps.
Thank you.
I thank you.
If there is no question, I can make a general conclusion and we can close the session. Thank you, presenters and participants. This session have very informative and updated studies in civil engineering discipline. We can see the connections between architecture, computer, civil, structural, hydraulic, materials engineering, geography, hydrology, water resources, and earth sciences, etc. disciplines, we cannot ignore new techniques as augmented and virtual reality, construction, post-tension technically, but we should consider the limitations, advantages, and disadvantages of these technologies. On the other hand, we need to estimate natural hydrological events as rainfall, snow, storm, hail, etc. by looking historical observations. So the design of structures or a part of buildings as roof, window, etc., rainwater harvesting for water irrigation or drainage of rainwaters should cover these estimations. According to demand, flood protection structures, dams, etc., need to be maybe required to protect cities from extreme events as droughts or floods, or produce hydro energy as clean energy. I want to thank you all, ladies and gentlemen. Thank you for your patience and thank you for your interest to this session. Yes, Dr. Roxana, thank you.
Thank you very much, Dr. Lal, for accepting to be the chair of the session. Thank you, dear authors. We are going to have also a lunch break eventually, virtual lunch break. And then we will start the afternoon session at 12 in Turkey time. Thank you very much. There is
thank you all.
Thank you all.
Thank you very much. Thank you, dear.
Thank you.
See you. Thank you.
Thank you.